Artificial neural networks, ANN, are a type of machine learning technique modeled after the structure of the human brain. ANNs work by creating an artificial neural network comprised of individual neurons with adjustable weights and thresholds that allows the system to learn. These networks are commonly used in applications like image recognition, sentiment analysis, and autonomous vehicles. One of the main components of a neural network is its layer structure. An ANN typically consists of an input layer, one or more hidden layers, and an output layer. The input layer takes the initial set of inputs, usually represented as numbers, and passes these inputs along to the first hidden layer. Here, the weights and thresholds of the neurons can be adjusted to refine or alter the data. The output of the first hidden layer is then processed by the second hidden layer, and so on. Finally, the output of the last hidden layer is passed to the output layer, where an action is taken in accordance with the neural network's output. This process is known as forward propagation. The types of layers used in a neural network can vary, ranging from the standard fully connected layer to the more complex convolutional layer. A fully connected, also known as a dense, layer is composed of neurons that are connected to every neuron in the previous layer. This type of layer is useful for problems where the data is simple and not particularly varied. Convolutional layers, on the other hand, are used in more complex problems, such as image recognition, where a convolutional kernel is used to group data and create a feature map. This allows the neural network to identify more complex patterns as opposed to a dense layer. In addition to fully connected and convolutional layers, there are also recurrent and pooling layers. Recurrent layers are used for sequence problems, such as natural language processing. These types of layers involve a recurrent neural network, RNN, in which a single neuron's output is fed back into its input, enabling the neural network to remember previous steps. Pooling layers are used to reduce the dimensions of a dataset and improve the performance of a neural network. They work by pooling or grouping similar neurons and returning a single value for all of them. All of these layers are used in combination to create a complete artificial neural network that can be used to solve complex problems. Each layer performs a different task, and all of them must work together in order to train the neural network accurately. As evidenced by the various layer types, the number of possible neural network structures is vast. The success of an ANN often depends on finding the optimal layer architecture that provides the best performance.